Right, so 4.6 quadratic functions in general form. This is going to look a little bit different than vertex form. So you might recall that when we had vertex form, it looked something like this. And we were immediately able to look at the equation and get our vertex coordinates, both our x and our y, from P and Q. And I could also tell you about the direction of opening and how much it was stretched based on A. Well, A stays the same in my new equation. So we see A showing up here and here. So I'm still going to be able to have an idea of the direction of opening and my stretch or compression by looking at A. But unlike P and Q, B and C are a little bit less helpful when it comes to putting on our vertex. So instead, there's a couple other pieces of information that we can figure out from general form that we don't usually solve for from vertex form, or at least not directly. So part one. C, that constant term at the very end, is actually your y-intercept. So this is exciting news. Your y-intercept is given away every time, right away. The second you have that constant term without an x attached to it, boom, you know. That's where it's crossing my y-intercept, or that's where it's crossing my y-axis. That is where I am going to plot that 0, comma, some number, whatever that c value is. In order to be able to figure out my x-intercepts, what I'm going to actually do is I'm going to have to go back to that strategy of way back in 3.2 where I was factoring, because remember, when we talk about x-intercepts, we're saying that y is always 0. We haven't moved left, or we haven't moved up or down at all. We're just moving left and right. Where is it crossing my x-axis? So just remembering those two pieces for x-intercept and y-intercept. Now, to figure out what your vertex is going to be a little bit more complicated. Option 1, and this is going to be the strategy that we focus on today, is going to be that we find the mean of my x-intercept. So I'm going to follow step 2. I'm going to factor to find my x-intercepts. And then from there, I'm going to take the average or find halfway between. Okay, so also known as the average, in terms of how you've done the calculation before. You'll notice it when we start actually doing it. Once we know the x value of my intercept, then I can, or of my vertex, then I can always solve for y. Our second strategy, we're going to save until maybe a little bit later on. I'll show you how to use it, but I'm not going to emphasize it now. It's going to be just use this equation here to solve for your x value of your y coordinate, or of your vertex. What letter had we used to represent that? Well, we would use the letter P previously. So let's put it in action, see how it goes. First of all, we look at this equation. Before I even read the question, I'm like, oh my god, there's decimals. Well, remember, we can factor out decimals, so it's no big deal. Don't sweat it. Okay, so let's take a step back, get over that fear of decimals, and look at the question. Given that equation with decimals, find the intercepts, the equation of the axis of symmetry, aka the x-coordinate of your vertex, also known as the p-value. Okay, and then solve for your actual vertex. Okay, well this is manageable. You can do this because your y-intercept, that's when x is 0. Now, if you don't believe what I said earlier on the page about how it's just your constant term, you can double check right now, and I'll prove it to you. Y-intercept is when x is 0. So plugging it into my equation, I've got negative 2.5, 0 squared minus 7.5 times 0 plus 10. Well, this term becomes 0 and this term becomes 0, which means all I'm left with is my constant. So my y-intercept is going to be my constant term, and that's why that is always the case. My x-intercept is a little bit more challenging. I have to factor. Okay, so starting with set it equal to 0 because y is 0 now. I'm going to take out those decimals that we really don't like so that it's a more manageable function. So I'm going to leave me with a simple trinomial, x squared plus 3x minus 4. Okay, now I'm going to leave that 2.5 on the outside. You could divide it away if you wanted to, but I'm just going to leave it there so I keep the integrity of my original equation. And I'm left with x plus 4, x minus 1. Those are my factors for this simple trinomial. Remember, sum and product. Okay. From here, that means that x must be -4 or it can be +1. So there we go. Those are my intercepts. Done and done. Not so bad, right? Okay, we're just going to be taking all our skills from this whole unit so far and putting them all together. And we're going to add a couple more. B asks us for our equation of the axis of symmetry. Now, I mentioned two strategies. Option 1 was finding the mean. Basically, all you do is you're like, okay, well, what's halfway between -4 and +1? Well, I add them together, so -4 plus 1, and divide it by 2. What's halfway? So in this case, -4 plus 1 is -3. It's going to leave me with -3 halves. Okay, now I realize that there's a typo in this equation here. So we're going to go back and add it in. It's -b over 2a. We're going to see that in a second here. Because my other option is to use that equation. So x equals -b over 2a. So that's going to be -7.5 divided by 2 times -2.5. Well, those end up being 3. So it ends up being -3 halves. So in either case, because it asks for my axis of symmetry, I'm going to have to state it as x equals. I really want to make sure that it's got that full equation to describe that line of symmetry. Okay. Finally, C is just a matter of figuring out, well, my axis of symmetry is my x value of my vertex, so I need to just figure out my y coordinate of my vertex. Well, I can do that by using my original equation. I already have y all nice and isolated. I just need to plug and chug in for x. So that's what we're going to do here. Y equals -2.5 times 3 over 2 squared, -3 over 2 squared, sorry, minus 7.5 times -3 over 2 plus 10. We're going to go from here. I'm going to convert it all to fractions so I can be comfortable, and I'm going to do it with mental math. You do not have to. If you want to use your calculator, you are more than welcome to. The stronger you are with your fractions, the better off you're going to be in the end. But if it's really slowing you down and you're kind of losing the thread of the math, I don't want you to lose track of the big picture. Use your calculator and maybe go back to that kind of like drill and kill booklet, that purple booklet that you've got where it's got like practice skills. See if you can find some fraction questions in there to practice. So I'm going to convert these to 5 halves times 9/4 plus, because I've got 2 negatives, got 15 halves times 3 halves plus 10. So that leaves me with -45 over 8 plus 45 over 4 plus 10. When we're dealing with fractions, we want a common denominator, so I'm going to have -45 plus 90 plus 10 all over 8 sorry, not plus 10, plus 80. And that's going to give me 115. Nope. 125 over 8. Okay, which kind of makes sense. Like that ends up being a pretty big number, bigger than my y-intercept, so that all kind of fits together. And I did check this value on my calculator in case you did use a calculator, and it should have been 15.625. Okay, so either way, you should have ended up with that as a value. Just like up here, you could have hypothetically said x is negative 1.5, and that is my axis of symmetry. That would have been okay too. All right, so those are all our steps. I know we blew through that kind of quick. The key thing will be to practice and use that information in the next example to actually put your parabola on a graph now.